Hello, welcome to Econometrics Melody. In this video, we will talk about the z-test. We have already covered normal distribution in our earlier video. Z-test, it emerges from the normal distribution, and we use z-test when the variance of the population is known. And if the variance of population is unknown, we use t-test, and we will estimate the variance by the help of the sample. Now let us prepare our data set and perform one sample z-test. Let us see the variable called gender, and let us summarize the income across gender. So the average income is 10,200, this value 10,233.762, and we want to test the hypothesis that the average income is 11,000. This is our null hypothesis, and the standard deviation of the population is 5,950, and we want to perform the z-test. So this is a two-tailed test, and we'll give the information on two-tailed as well as left-tailed and right-tailed test. Standard error, we calculate the standard error by dividing population standard deviation by root sample size, root n, and let us use the formula and calculate it, and we see the same value. Population standard deviation divided by square root of n, the standard error 14.58. both of them, they have the same value. Similarly, how do we calculate the z score? Z score is equals to sample mean x minus mu. Mu is the null mean, that is 11,000 in this case, and divided by standard error. Okay, the z score is minus 1.862, and we get the results are same. Similarly, how do we calculate the p-value for these three alternative hypotheses for two-tailed and one-tailed test? So let us remember the values. So it is 3%, 6%, and then 10%. And let us see whether we get the same value or not. 3%, 6%, and 10%. 3, 6, and 10%. So these are some of the useful formulas. Now let us again perform the z-test. So we get the table, and this is our OGT. This is our program that we have written, and that takes the value of the sample size, sample mean, and population standard deviation, and the hypothesized mean. And let us see, we'll get a graph, and we'll try to explain both the z-tailed, two-tailed, and the single-tailed test. The significance level, we have taken it to be 5%, and for this 5%, the z score is 1.96. So in other words, the significance level 5%, it is the excluded area between plus minus 1.96. So the area marked by this yellow color, it is 2.5%, and another towards the right, we have again another 2.5%, which adds up to 5%. So this is a kind of a threshold. If we are able to cross this threshold and reach towards the region, towards this mean of 0, then we say that in that case we fail to reject the null. And if we are unable to break this threshold and we lie quite away outside from this threshold, then in that case we reject the null and we accept the alternative hypothesis. So this is the basics. Now let us see, our calculated z score is minus 1.8622, and which is able to break this threshold. And if we see it, so this part it is minus 1.8, and this part it is minus 1.96. So in this case we fail to reject the null. In other words, we are saying that we belong to this null region, we lie inside this null region, because we broke this threshold and we entered inside. Now let us base our analysis based on the p-value. So the p-value is greater than our significance level, that is why we fail to reject the null in this case. Now let us base our analysis based on the z score. So the absolute value of the z score, if we see it, it is 1.8, and the tabulated z score, it is 1.96. 1.8 is less than 1.96, that is why we fail to reject the null in this case as well. So for two-tailed test, we fail to reject the null. Now let us see our one-tailed test. So right-tailed test, the p-value is 96.90, so it is greater than 5% significance level, so we fail to reject the null in this case. Now let us see our left-tailed test, as the p-value is less than significance level, so in this case we reject the null. Another set of commands that will produce the same result but we are going to use the Z score only. So the same result, we were able to break this threshold that we have set, marked by the yellow region, and in both of the cases. So for the two tail test, we failed to reject the null. It is very evident. For right tail test, the p-value is greater than 5%, so we fail to reject the null. Left tail test, p-value is less than 5%, we reject the null. Now let us see how do we perform one sample Z test when the information on cluster and the intra-class correlation is provided. First of all, let us see how do we calculate the intra-class correlation. We use ICC command, and the intra-class correlation is minus 0.005, and we use the same value to perform the Z test after incorporating the cluster and the intra-class correlation. So our Z score is minus 2.10, and our p-value is, let us call it 2, 3 and 98. 2, 3, 98. Let us see whether we get the same information or not. Z score is minus 2.10, and here we have 2, 3 and 98. Now let's see whether we are able to cross this threshold of 1.98 or not, because our significance level is 5%. So we have a threshold at the value of Z 1.96. So 1.96 it is marked over here, and if we see our calculated score, it could not break this threshold. That is why we are away this null region, so we reject the null hypothesis. For the two tail test, if we compare our p-value, it is less than the significance level. That is why we reject the null. Now let us perform our one tail test. For the left tail test, again the p-value is less than 5%. That is why we reject the null. And for the right tail test, as the p-value is greater than 5%, so we fail to reject the null. Now let us perform the two sample Z test, and let us again tabulate the gender. So tabulate the income across gender. So the average male income and average female income, standard deviation, and we want to test the hypothesis whether the average male income and average female income, they are same or different. So we make help of the difference. First of all, let us perform the test, and we want to provide the population standard deviation for male and female. They are 5500 and 6200 respectively. The difference of the income is actually 1300. So can we say that the female earn more than the male, because the difference is negative over here? Let us see how do we calculate the standard error. So for the standard error, we use this formula: sigma 1 square divided by n1 plus sigma 2 square divided by n2 and its square root. And let us see whether we get the same result: 837, 837. So this is what we get. And how do we calculate the Z score? We calculate the Z score by the difference of the mean income of male and female divided by its standard deviation, and we get the same Z score, minus 1.55, minus 1.55. And for the p-values, we have already seen it in our earlier example as well. And let us remember it. It is 6%, 12% and 93%. 6, 12 and 93. 6, 12 and 93. It is that simple. Now let us again see the Z test table, and then we will try to depict it by the help of our graph as well. Z score of minus 1.55 and the p-value of 6, 12 and 93. 6, 12 and 93. 6, 12 and 93, and Z score of minus 1.55. Now let us see again, for this 5% significance level, the threshold point or the Z score is 1.96. So we have 1.96 over here, and this calculated Z score, whether it is able to break this threshold or not. And if we see it, it is very clear that we were able to break this threshold, and we came to this point, that is minus 1.55. And at a glance, we can say that we failed to reject the null for this two-tail test. As the p-value is greater than our significance level, we fail to reject the null, which is very clear for the two-tail test. For the one-tail test, let us see first of all the left-tail test. Again, the left-tail test, the p-value is greater than our significance level. We fail to reject the null in this case. But for the right-tail test, the p-value is greater than our significance level. That is why we fail to reject the null. So in both of the cases, we fail to reject the null. So our null hypothesis, the difference is 0, meaning thereby male and female, they earn same income. For this two-tail test, let us perform use this option called unpaired. We can use this option called unpaired, and then let us make an analysis by the help of the area graph. By the graph, it is very clear that for the two-tailed test, we fail to reject the null, and both the left tail and right tail test, the p-value, they are greater than 5%. That is why we again fail to reject the null. Now let us adjust the cluster and inter-class correlation and perform the two-sample z-test. So we can use this option, cluster, our country variable, it represents the cluster, and we calculate the inter-class correlation, and then we substitute the value over here, and let us see what do we get, and we'll explain it by the help of graph. First of all, let us run the test, and our z score is minus 1.63. The p-values for the left tail, two-tailed, and right tail test are 5, 10, and 94. 5, 10, and 94. 5, 10, 94 minus 1.63, 5, 10, and 94. Again, if we, graphically it is very clear, we can say that we fail to reject the null for two-tailed test because we are able to cross this threshold, surpass this threshold, and come inside this region of the null. So we fail to reject the null in case of two-tailed test, and again in case of left tail and right tail test, again the p-value is greater than 5%. We fail to reject the null in this case as well. Now let us see the example of two-sample z-test using variables, that is unpaired test, and we will see calculate its formula as well. First of all, let us again tabulate, see some of the tabulation. So the two variables, their average mean is this, and their standard deviation is also given, and we want to test whether the mean they are equal or different. And let us see what does it look like. Actually, it is an unpaired test. The two variables are not the paired variable, and their population standard deviation for the first variable is 5900 and the second variable is 3100. And this is our tabulation, and we want to see how did we calculate this standard error, and we use this formula, square root of sigma 1 square divided by the sample size, sigma 2 square divided by the sample size, and they are independent. We assume they're independent, that is why we didn't take their covariance or the correlation. And let us see we get the same value or not. It is 459.97, and this is what we get. They are one and the same. Let us see how do we calculate the z score. Z score is actually the difference of their mean and divided by the standard error. Let us tally it with the result. It is 11.67, and we have already seen how do we calculate the p-values for two-tailed and left tail and right tail test, and let us remember them. It is 1%, 1 0 0 1 0 0 100 1 0 and 0. That's it. Now let us run the test once again, and by the help of the graph we will see whether we get the same result or not. 11.67 and then 1 0 0. 11.67 1 0 0. This is 11.67, and we have 1, meaning they have 100%. 0 and 0, they are one and the same. This is what we see. So our p-value for the two-tail test is 0. A 0 is less than 5%. We say that we reject the null, and which is graphically it is very clear. The message is very clear. This score, it does not belong to, there is no way that it belongs to this region. It is quite away from it. That is why the null hypothesis is rejected. Now let us see the examples of paired z-test, and let us first of all see the correlation of these two variables. Their correlation is actually minus 2%, and let us see their mean and standard deviation, what it is like. Now let us perform the paired z-test making use of the information of correlation. First of all, we are creating a variable called difference in their difference, and we will make use of this variable in order to calculate our z score, and its mean is 5370. That is what we have taken to perform our z score, calculate the z score. Now let us perform the paired z-test, and we use the information of correlation as well. We have provided the information of correlation as well, and let us see how do we calculate the standard error. So we make use of sigma 1 square divided by n plus sigma 2 square divided by n minus twice sigma 1 sigma 2 into the value of correlation divided by n. and let us see whether we get the same result or not. It is 464.6273, 460.6273. And how do we calculate the JD score? We calculate the JD score by taking the difference, its mean of the difference, and that we have calculated it 5370575 and divided by its standard error. And let us see we get the same result or not. 11.5593, 11.5593, both of them are the same. Now let us remember the p-values for a left tail, a right tail, and the two-tail test. It is 100 again, 100. We get the same result. These are some of the formulas, useful formulas. Now let us make an analysis. First of all, let us again carry out the z-test, and based on the area graph, let us remember this again: 11.55 and 100, 11.55 and 100. Again, seeing this graph, the nature of the graph, we see that we outright reject the null. We reject the null. So for two-tail test, we reject the null either based on the JD score or based on the p-value. And for one-tail test, for the right tail test, is our p-value is less than 5% or alpha value, that is why we reject the null. But for left tail test, is our p-value is greater than our sigma alpha value, that is why we fail to reject the null. For right tail test, actually we reject the null and we say that the difference is greater than 0, and the difference is greater than 0 only when we have the value of this in the first variable to be greater. The mean income of this is greater than this. If the first variable represents the income before an intervention, and if the second variable represents the income after an intervention, then we see that after the intervention, the income has declined very sharply. Actually, this is the hypothetical data. So this is how we could have made our analysis had it been a real data. After intervention, the income had decreased. So in case of common standard deviation, we perform the z-test in the following way by providing following options. And let us see it by the help of graph. First of all, let us run the test, and the JD score is 8.07, and again 100. In two-tail test, we reject the null. For right tail test, we reject the null, and for left tail test, we fail to reject the null. We can perform the paired z-test by providing the information on standard deviation of the difference as well. And then let us see what does it look like. Again, we get the same result, a similar result than the previous one. So for the two-tail test, we reject the null. For the right tail test, we reject the null, and for left tail test, we fail to reject the null. And this time we are going to take the alpha value to be 1, and let us see what happens. So the area on the right hand side, it is 0.5% and 0.5% on the each side. So for the two-tail test, p value is less than our alpha value of 1%. That is why we reject the null. For right tail test, we again reject the null because this value is less than our alpha value, and we fail to reject the null in case of left tail test. Now let us perform our z-test by providing the immediate inputs. This is our sample 1200 and the mean of the sample and the standard deviation of the population, and we want to test the hypothesis that the mean income is 250. And let us see what does the table look like. This is our information. The z value is 34, meaning thereby plus minus 34 standard deviation. So let us see what does it have to offer. 100 is our p-value. So this is 1 0 and 0. So in this case, for two-tail test, again our alpha value is 5%. So is our p-value is less than 5%, we reject the null. For left tail test, we fail to reject the null, and for right tail test, we reject the null. And let us see another example where the sample is 1200 and its mean is 300, the population standard deviation is 50, and we want to test the hypothesis whether the mean is 250 and the significance level is 99%. And let us depict the same information by the help of the graph and make an analysis again. We compare this based on the p-value. We see that we reject the null because p-value is less than our alpha value. Left tail test, we fail to reject the null because p-value is greater than alpha value. Right tail test, we reject the null because our p-value is less than the alpha value. Now let us perform two sample z-tests providing immediate inputs. So the first sample, its mean and its population standard deviation. Second sample, its mean and its population standard deviation. And let us see what is in its tabular form. We get this result. Again, our z value is very greater, -33. And let's show this information on the graph and make an analysis. Again, for the two-tail test, we reject the null. Again, based on the p-value for our two-tail test, we reject the null because our p-value is less than our alpha value. And based on the z-score, as the absolute calculated z-score is quite greater than the tabulated z-score, we reject the null in this case. Now for one-tail test, for left-tail test, we reject the null because the p-value is less than the alpha value. And in the right tail test, we fail to reject the null because our p-value is quite greater than our alpha value. Now in another example, we are simply changing the significance level to 99% and we should not see any change in the analysis. We get the same result. Simply this threshold or the benchmark 1%, the total area is 1%. So this is it for this tutorial. Thank you very much for your time. Thank you very much, Econometrics Melody.